this video, we will see the definitions of ideal machine, actual machine, ideal effort and ideal load. So let us start with the first part, that is ideal machine. Ideal machine is that machine in which friction is absent. So here I'll write down that is defined as a machine in which there is no friction. And when there is no friction, we mean that efficiency is 100%. Efficiency is 100%, therefore mechanical advantage is equal to velocity ratio. Such machines, they are impractical. We don't have any machines which are ideal, that is 100% efficient. So here we can say that such machines are impractical. So this was regarding ideal machine. Next, actual machine. It is defined as a machine in which friction is present, then efficiency of actual machines, they are not 100%. So efficiency is less than 100%. It means mechanical advantage will be less than velocity ratio, because we know the formula of efficiency. Efficiency is mechanical advantage, that is ma upon vr. So if ma is less than vr, then only the efficiency becomes less than 100%. So actual machines are practical machines. The next definition is ideal effort. Ideal effort, it is that effort which is applied in a machine, or we can say in an ideal machine. So ideal effort, it is that effort which is applied in an ideal machine. Ideal machine means no friction. So ideal effort, it would be denoted by P suffix I, that is ideal effort. And the relation we can get of ideal effort, I'll say that since ideal machine is there, so mechanical advantage is equal to velocity ratio. Therefore mechanical advantage is load upon effort is equal to VR. Finally I will keep effort on one side, therefore P will be equal to W upon VR, and since we want ideal effort, I'll write down suffix I here. So ideal effort is given by W upon VR. Here is the relation of ideal effort. Next is ideal load. Now ideal load, it is a load which is lifted in an ideal machine. Means a machine in which friction is absent. So therefore ideal load would be denoted by W suffix I, and the relation again we can get it from mechanical advantage is equal to velocity ratio. This relation we are using since efficiency is 100% for ideal machine. Therefore, mechanical advantage is load upon effort. It's equal to VR. So finally, W will be equal to P into VR. P gets multiplied there, and here I'll write down suffix I because it is ideal load. So here is the formula for ideal load, and ideal load would be there in case of ideal machine, that is how much load we are lifting in an ideal machine when there is no friction. Ideal effort was the effort which we apply in a machine in which friction is absent. So in this video, I think whatever the definitions I have expressed, it is very much clear.